Hi, everyone. Welcome to another episode of Pints with Ayre. I'm Brent Heffley. I'm the Sales and Marketing Director for Ayre Acoustics. And I'm here, as always, with our wonderful Ariel Brown, VP and Senior Engineer, and Ryan Berry, our CEO and Expert Technician. All right. Cheers, guys.
Cheers. Cheers.
Cheers, everyone out there. Hope you're doing well. It is summer here. Full on. It's supposed to be in the hundreds in Oregon this weekend.
Oh, wow.
Yeah.
95 here today.
All right. Right. Nice and toasty, just like we like our amplifiers, right?
Yeah.
We'll get to that in just a minute. But first, as is our tradition, what did you guys pull out of the refrigerator today?
So another relatively local brewery, Funkorks. They're up in Fort Collins.
Oh, nice.
First, we got their Belgian style Saison.
Oh, I love Saisons.
Yeah. Yeah. It's one of
They
my
pair well with high fives.
Nice.
Oh, nice.
All right.
At least you used to.
Yeah, it's a perfect weather for Saisons. It's nice warm day, nice light.
Nice light and crisp. Yeah.
The farmhand lunch beer, right?
Exactly.
Like that's sure it is. That's what we need.
Yep.
That's what we need. Help finish all that firmware code and stuff with those. Cool. I went fairly local. I mean, it's just over the mountains. It's Three Creeks Brewing, and it's in Sisters, Oregon. So this is one of their IPAs, the crowd pleaser, of course. And one of the cool things about the can that I noticed when I just pulled it out now is the top is black.
Oh, interesting.
Yeah. I'm like, what is that about? I
I
mean,
mean, you
I
can
don't
pick
think it
any
has
color
any
you want, I
function, but it's
suppose.
kind of cool. You can do it, right? Like,
Yeah.
it's not just a silver can,
Absolutely.
but it's a really nice IPA. Maybe a little heavy for 100-degree weather, but we're only about 77 degrees right now, so it's all
Get
good.
it in while you can.
Yeah, exactly. So excellent. Well, today we are going to talk about the topic of amplifiers, and specifically class of amplifiers. I think anyone watching this has probably heard the term Class A, Class AB, Class D. But what do those mean? What type of effect does it have on the sound, and why do we do what we do? Are kind of what we're gonna look at today. And if you want to just start off with a little survey, Ariel, of the different classes that are out there. And
Yeah. So first start off like what changes, Lisa? So that generally refers to more or less the quiescent bias of the output stage. And so if you're talking about, start with Class A. And so the output transistors, whether it's a single device or it is a push pull pair, kind of like we use,
right,
it doesn't really matter. So for Class A, what that means is that the transistor is biased high enough such that it never turns off. So it is always on and passing the signal, so that it, which means, if you're talking about, an actual power amplifier output stage, it has to be able to provide enough current to actually drive the load without ever turning off itself.
Okay.
And so for a actual power amplifier, that's pretty extreme.
Right.
And so the cost there is heat.
Mhm.
We're talking about a power amplifier output. That cost is heat.
Yeah.
So if you look at the next, so talk about a Class B, that's where particularly applicable to push-pull output topology, where there is no bias in either of the top or bottom transistors. And so when the signal goes high, the top transistor turns on. The signal goes low, the bottom transistor turns on. And so the benefit there is you don't have that quiescent heat that you have to dissipate. And so it runs very cool. The cost there is that transition from the top to the bottom transistor. You get quite a bit of what they call crossover distortion. So when a signal, goes above or below zero at that transition point, that's not very linear. And so that's where Class AB comes in. And so it's kind of a middle ground between the two. So where you have a modest level of bias in the output stage in that pair of output transistors, such that it eases that crossover point quite a bit. It's still not perfect, but it sort of reduces that crossover distortion significantly.
Right.
And so that's the most common power amplifier output topology. Because that is, the best compromise between heat and distortion.
Right.
So obviously the Class A output stage will typically have, it will be the most linear and therefore the most the least distortion, because the transistor never turns off, never has to hand off to the other transistor. It will always be on. So
great. So before we go too much farther on that, can you just give a brief description of what bias is? I'm sure everyone's heard the term that's watching this, but may not know exactly what's that mean, like when you're biasing that piece.
Yeah. So bias is, so that usually measured when without any signal, that there is you have a quiescent current flowing through the output devices. So it's just so in our case, when we have a push-pull topology, from the positive rail through the transistors to the negative rail, there's nothing flowing out to the load. There's nothing flowing in from the input. It's just that we have some bias current, so that there's kind of an idle, also called idle current, in the output transistor, so that they are more, in a way, primed and ready to go.
Okay, right.
So they're already turned on, and so in a Class AB output stage, for very small signal levels, the output stage is actually acting in Class A, which is why it's called Class AB, because for smaller signals, it is still operating in Class A. And then once the signal gets too big, then it transitions over to Class B, where once the signal is too high, the bottom transistor actually fully turns off because its bias current has been fully depleted by the needs of the load, and now it's being fully provided by the upper transistor, and vice versa when the signal is low. That's when it transitions to Class B, when one of those transistors has fully turned off. But for the small signal levels, it is actually operating in Class A, because both transistors are still they still have current. They're still turned on in the region.
Right. Okay, great. So the side effect, as you mentioned, for Class A is heat, right? It's very low distortion, but it's a lot of heat.
Yeah.
I mean, like, the perfect amplifier would be an all Class A amplifier, but to get enough power out of it to hit, some of the power ratings people would want, you'd be looking at an amplifier the size of a room that would have to be outside of your house so it doesn't heat the whole house up.
Right. Yeah, and so also we should make the distinction here that for that specifically, we're talking about a power amplifier output stage now, and so that's where running Class A really does not become practical. Now, for almost every other stage of any source or preamp or the input stage or the driver stage within any of our amplifiers or sources of preamps, we always make sure to run those in full Class A, and it's much more practical there because you're talking about much lower currents. You're only talking usually a few milliamps, or maybe a few tens of milliamps, which is really easy to actually deal with.
Right. So we carry that through the signal path all the way. And then when we get to our amplifier output stages,
The final, the final transistor output stage, yes.
Yeah.
But even the driver stage supplying or feeding our final output transistors, those run in Class A as well.
Cool.
Yeah, so we're running basically just the amplifier stage.
Right. Right.
The
Yeah.
output stage,
Right.
Yeah. Because we don't want to heat the house to 1,000,000 degrees. Like,
Well, you know, big amp. A lot of heat sinks.
could we have like a summer and winter setting on the back? You know,
Eco mode.
Eco mode. Eco mode and
Yeah.
house heating mode.
right. So obviously, Class B is a pretty is really not acceptable as far as a high-end audio product. It simply has too much distortion. It is fairly audible. It's just not going to sound as good.
Right.
You know, like I said, Class A would be great if you're talking about a really, really low power amplifier. But a well-designed Class AB like we've done for 28 years now, and as well as most high-end audio companies make. It is the best choice ultimately.
Right. Yeah. It sounds like the best compromise where it's not really full on Class A in the output, but you reduce the heat, you increase the power, you've got a lot more flexibility and
Sure.
the ability to drive speakers in a
Right.
better way. Yeah. Now there are other classes that people use out there, obviously, even in high end. Do you want to give a little survey of what those are?
Yeah, well, yeah. So obviously, the one that is most talked about and becoming quite more popular in some circles is obviously Class D,
Right.
which is more or less, you can call it a digital technology, but it's it's really just it's more of a switching amplifier. And so the way that works is that it gains a lot of efficiency because the way it works is that the output transistor is either on or off. There is no middle ground like a analog output stage. And so at that actual transistor level, it's the transistors are on or off. And so that's much more efficient for the transistor because there's either voltage and zero current, or there's zero voltage and a lot of current. And so, and then so it's very, very little time that the output transistors are actually generating any real heat. And so they run much cooler, and therefore they're very efficient. But so, that signal that they essentially generating is related to the audio signal. So it's generally, basically a kind of pulse width modulation. And so if the analog signal that you're trying to end up with is high, then the average of the PWM will be usually high. And if it's at zero, then it'll be equal high and low. So it would basically be a 50% duty cycle square wave if it was just at zero with no signal. And then when the signal is low, obviously the duty cycle would be much, much lower. Right. So that the duty cycle basically represents what the analog signal level should be. So then that has to be filtered and then with passive components to then be to then recreate the analog waveform that you want to drive your speakers with. And so again, the big pro there is basically efficiency, heat, and cost, because you don't have to deal with the heat, all those things. And so there's a lot of efficiency gain there. I think that the big drawback is for us is that is what we feel is sound quality, and converting to that digital like domain, and then having to filter out all those higher order harmonics to get back to that pure analog is imperfect at best.
Right. Right.
So it just creates a lot of noise that you have to
Mhm.
filter out.
Yeah. Is it easier to build a Class D amplifier less expensively than a Class AB, or can either one be done at lower price? Kind of the same.
Class D is certainly generally cheaper to cheaper to design with, because you can have much smaller output stage, much smaller heat sinking. You can have a smaller power supply because the output stage is far more efficient.
Mhm.
Mhm.
So there are a lot of cost savings there.
It's
Right.
really shocking how much the transformer really costs in a design. It's a pretty penny.
Yeah, especially in today's world where costs on all materials are going up and up and up.
Right.
Absolutely.
Yeah.
Now, if you're talking about, a true high-end Class D amplifier, to really get that output filtered well enough to have a really good output signal, you probably have to have a complex enough and large enough analog filter afterwards that you're probably offsetting some of those costs, and so it
Sure.
may not to actually do it reasonably well.
Right.
Other those costs probably creep back in.
Right.
But
Okay.
I haven't designed one that way, so I
Okay.
can't say for sure.
All right. Cool.
There's always something to spend money on.
Yeah, exactly. Exactly.
Alright.
Uh,
So there's only one or two others that are worth knowing that probably most people haven't heard of.
Uh-huh.
So I think it's Class G and H are really variations on a Class AB, and what
Uh-huh.
they do to gain essentially efficiency as well as some a power dissipation savings is that they modulate the power rail to the needs of the signal. And so
Oh,
otherwise it's the same, but then just the power supply shifts as needed, so that if it's not so that if the signal level is low, the power supply doesn't need to be quite as high, and so the power supply can be
Right.
brought down so that the dissipation across the output transistors can be reduced quite a bit,
Uh-huh.
which is a pretty intriguing idea. Certainly some complications there
Sure.
to the power supply for sure. I know that I think pretty sure RCAM has done a fairly successful Class G output stage a few years ago.
Uh-huh.
Yeah,
Nice.
I
Yeah, that's
talked
interesting.
to John Dawson about that, and he was relatively proud of that, and it was actually pretty impressive. So that you can get probably some really high performance out of that and gain some of that efficiency back
Uh-huh.
if that's done well. But again, that will potentially compromise the power supply, if that's not done really, really well.
Right.
But, that's something that I've been thinking about. I haven't done any actual experiments with it, but it's intriguing.
Yeah. No, that is intriguing. It's cool that they did one.
Yep.
Yeah. Awesome.
Right.
Well, yeah, that's I think that's a great summary and great explanation. Unless you have anything else to add, we can.
Yeah, I'm probably forgetting something, but
We always forget something, right?
yeah.
We'll do an episode of all the little things we forgot,
boy.
and it'll be completely random, out of order. So you'll have to go and like match it to the episode it came from, like outtakes.
Right. Yeah. So that, I mean, I guess one thing to add, so in our Class AB designs, so there is some bias in the output stage, and so part of the trick or the magic is basically getting that bias right.
Mhm.
Because getting that bias right affects the distortion. It definitely affects the sound quality. Even if you shift it just a few milliamps,
I think it's a sweet
has a
spot.
dramatic effect,
Right.
both in measurements as well as sound.
Yep.
And there's that and at least currently we use bipolar outputs, so they have a certain is almost a sweet spot for them. Whereas, some of our very, very early designs, like the V3 and the V1, they used MOSFET output stages.
Right.
And what we found there was that basically the higher the output bias, the better. And so we're just limited pretty much by the idle heatsink temperature that you could live with.
Right.
The only problem is they're really bipolar.
Yeah, you never know what's showing up. Yeah, so you're saying I shouldn't just go open my AX5 upstairs and just crank the bias up on it? It's not.
I
No,
probably
the
wouldn't have messed
AX5.
with anything inside of it.
Yeah.
Now the X5 with the V1, yeah, crank
right.
it,
All right.
crank it as high as you're willing to go.
Crank
I know.
it
I
high
mean,
as-
like what Ariel said, we've done a lot of listening tests. We've played with them higher and lower biases, and play with resistor values around them and everything else to try to find exactly where they sound the best. And that's exactly where we sit them on those. Fortunately, we haven't had to really make any compromises in that regard for worrying about somebody picking it up and scalding themselves versus
yeah.
where they want to sit or anything like that. So they're all in a really good place, and that's kind of the goal. So we design around that idea, and like you said, don't open up the amplifier and think you can turn anything up. And all of a sudden it will sound better, because this is not the case.
No.
Yeah. Perfect. All right. Well, thanks to everyone for watching. Hope you're doing well out there. If you have questions about this, or you have topics or questions that you want to see us answer
Please.
on another episode, let us know. pints@ayre.com. And until next time, happy listening. Cheers, everyone.